All right, I'm very excited about this one. Today we're going to talk about the LHC versus the Legacy Preamp. The Legacy Preamp is shipping in Spectre Euro bases, and to all accounts, it is a Hazlabs clone, just like the LHZ is. In fact, we've advised customers not to swap out their Legacy for the LHC because of that. However, we've had several people come to us in the last several months saying that it just doesn't quite feel the same and it has kind of a darker tone than their NS2s that have a Hazlabs preamp, and asking if it's worth doing an upgrade. So after a couple upgrades, we did have a client send us their old Legacy so we could put it on the bench and see what's going on there. So today I just kind of want to share what that process looks like and what we found in that comparison to see if this makes sense. So how we do this is with a stress test. When we think about preamps, the story isn't just about the EQ response. There's a few other things going on inside there: the overtones, the harmonics, the dynamic response of the preamp. So we do this with a set of tests that is kind of like a stress test. We push that preamp to the edge of its normal linear operating range until it gets into the nonlinear zone, and then we capture the response from that. And that gives us a sort of unique fingerprint for that preamp and the op-amp chips that are used, so we can objectively tell the difference in the sound that comes out from it. So how do we do this? There's a few things. The first one is we use a 20 hertz to 20 kilohertz sweep file, and then that's followed by a series of sine waves that run at 250 hertz, 500 hertz, 1 kilohertz, 2 kilohertz, and then 10 kilohertz. And these are all sent at different volume levels, ranging from levels that correspond to just soft playing all the way up to what I would call abusively heavy, aggressive playing. This will give us a good profile of how the preamp responds to dynamics and volume as you play it. So what have we noticed during testing? The first one is the chip. The LHC uses the 33172, which has the same sonic fingerprint and response as the original LF442CN that was used in the Hazlabs preamp. We went through testing of this a couple years ago. We've tested dozens of different chips and finally settled on the 33172, which is the same chip that Hazlabs is currently using on their new Hazlabs preamps. By comparison, the Legacy is using the 5532 op-amp, which is an excellent hi-fi op-amp. However, it just responds slightly differently than the op-amps we use in the LHZ. So is the Legacy a true Haz clone? Well, it does have one more component on the board than the Hazlabs and LHZ, so there is something different about the circuit. However, we're not going and tracing the circuit for this test. We are just going to rely on doing our stress testing and look at these overtones and harmonics that come from it to make our determination there. So the first thing we notice is that the current draw between these two preamps is different. The LHZ, like the Hazlabs, draws less than 1 milliamp of battery current when it's in use. The Legacy draws about 6 milliamps, so quite a bit higher. Not enough to run your batteries down quickly, but noticeably different. The next thing is that bass frequencies under 100 hertz are reduced with higher harmonics on the Legacy. If you flip back and forth between the baseline LHZ and the Legacy, you'll see that the bass curve kind of falls off there, and we see an increase in harmonics at that level. This is likely due to the op-amp going into its nonlinear zone earlier than the op-amp that we use in the LHZ. And this also likely accounts for that different feel because you're able to push it into the zone easier than you would on an LHZ or Hazlabs. Likewise, we also notice a roll-off of high frequencies above 10 kilohertz. This is noticeable when you compare the sweep form at normal playing volume. The LHZ, like the Hazlabs, has an hourglass shape, with the bass and the treble being boosted with a dip in the middle. The Legacy has a noticeably reduced treble above 10 kilohertz. When we zoom out to the full spectrum view, we're going to see the same set of sweep files and then sine tones repeated multiple times. On the left side, this corresponds to levels that are what I would call abusively aggressive. And on the right-hand side, that would correspond to very soft playing. Looking at 9 volts for the LHZ, we'll see that the 10 kilohertz overtones start coming in at about a moderate volume level. On the 9-volt legacy, by comparison, you see the low overtones coming in even when you're playing softly. Looking at the 18-volt LHZ, the 10 kilohertz overtones start coming in at an aggressive volume. And this is what we expect. When you move up to 18 volts, you have more headroom, so therefore you really need to start digging in before you get those harmonics. By comparison, 18 volts on the legacy, we see that those low overtones come in really early, but the 10K overtones only come in when you're abusively aggressive. So there's definitely a difference on those harmonic overtones and how early they come in when you're playing them. So some folks may counter that this sort of stress testing isn't accurate because it doesn't really represent what a bass guitar does. When you think about the fundamental frequencies of a bass guitar, you're generally talking 40 hertz to around 400 hertz or so. But you have to remember there are a lot of harmonics and overtones that come out of a bass. If you look at the graph here, this is just straight outputs from a PJ pickup set on a Spectre bass, as playing the entire range of the instrument, doing picking and slapping and popping all over the fretboard. And you can see we have frequencies all the way up to 20 kilohertz. This is why we do stress testing with the entire range from 20 hertz to 20 kilohertz, because all of these frequencies matter. All right, so what did we learn today? The first thing we found out is that the high frequencies are definitely cut above 10 kilohertz on the legacy. The legacy response is nearly the same as the LHZ was when we were beta testing and using the 5532 chip. So we think a lot of this is coming from the chip, but there may be some board differences as well. There's definitely a higher current draw on the legacy than there is the LHZ. From a sound perspective, that makes no difference. This really translates into battery life over time. It's a little easier to push the legacy into its nonlinear zone, but with that reduced treble and different profile of harmonic overtones, it's going to feel a bit different. It's important to note that most users will not hear the difference. We hope this is helpful. We hope it makes sense for those of you that feel like the legacy is a little darker and a slightly different dynamic response. It's not in your heads. There is a bit of difference, but I just wanted to put this together just so we could put some objective science behind what several people are noticing. That's it. Till next time.